NXP Semiconductors.
And these boards, demonstration boards, are fairly large. However, the near-field magnetic induction radio is very, very small. It's the size C chip down here. And so what we're going to be doing is we have two radios, one here and another one here. And we're going to be using those to see, first of all, how they work, separating the gap, showing that a human body does not interfere with the operation of the devices. So what I'm going to do, the way they're set up is the one on the left is set up to be an MP3 player. The one on the right, right is MP3 player. Left is just a receiver to be able to play music. That'll give me a good indication. If the music cuts out, then that means I am interfering with the device. Both boards have exactly the same software. The position of the button sliders determines what software it's going to run. So this one's configured up, down, and this one's configured both up, so this will be the receiver. And just as it would with the traditional MP3, I'm going to go ahead and power up the first board. And I can see the display tells me that I'm going to be in MP3 mode. I'm going to go ahead and hit button 4, which is up here. I'll hit that button. And now what the display is showing me 000, that there's no connection. I am going to take these two boards and align them for the best reception, which would be the two antennas in this direction. So rotated axially this way, so the axes of the magnetic induction antennas, which we can see are very, very small. Those are the ones that we're going to line up. I'm going to power up the second board. When I do that, my display changes now, and it shows a 102, meaning I have found another device, one more device on the network. 0 means that it's performing very, very well. Good connection. What I have out here is audio input, and I'm going to run music, some classical music, so we can hear the performance of the radio. And then I come back here and I hit start. The music starts playing. So first of all, what it shows is that it limits range by proximity, so that if the person were, my phone took an email, as I separate the units, it would naturally cut out and give me a safety barrier to say, hey, if the tool is more than an arm's length away, it won't receive and the tool won't run. The second thing with magnetic induction radio is it is not affected by the human body. So I could take this antenna, unlike an RF antenna, especially 2.4 gigahertz, if I were to grab it or hold on to the antenna, I would get 0 reception. With this one, I do not. Transmits right through the human body. So now to demonstrate or to check, my first application is I'm going to take a power tool, DC powered. I'm going to place it directly between the magnetic field and see if it interferes with the music playing. The music should be loud enough that I'll be able to hear if it keeps running. You can see the music keeps playing fine. It is not affected by the magnetic of a DC motor. This is a low-end tool, so I would think it's a Mansfield brand, so I would think it's fairly noisy. I can turn the tool around in various orientations. I've verified it is not blocking the magnetic induction radio. So that is the good news on it. Now I have a very old Craftsman AC motor, which will be very, very noisy. And that does, in certain orientations, does block the music. So I can tell if I come in here, the music is still playing. However, as I get closer to the magnetic induction radio, so the music still keeps playing. It does get packet dropout. Normal tool, decent spacing. Does not affect it, but if I bring that arcing motor near the magnetic induction antenna, I do get drop packets. But it does seem would obviously be a key for designing in such a device, but very low power consumption, the ability for it to limit the distance away from the tool, all those features should be a great benefit for doing such a design. Let me know if you have any other questions. Thanks.